Hey, this lesson is on knowing how to graph a square root function and cube root function. So, start with, the parent means the simplest form. So the simplest form is simply the square root of x. Can you write that down? We are going to do a table of values. And then we're going to plot the points and understand what the picture looks like and if there's any domain restrictions. So first, can anyone think of, and you don't have to go in any order, can anyone think of a good x value to plug in to get a point on my graph? 1. I heard 1. I'll start there. What's the square root of 1? 1. So let's find 1, 1 on my graph. I heard another number. 0. Can you take the square root of 0?
Yes. No. Yes.
Is there a number times itself that equals 0?
0.
So the square root of 0 is... So 0 is a good number for square roots? 4, I heard. The square root of 4 is... Hello. Thank you. Can anyone else think of any other? How? What happens if I put in -1? What's the square root of -1? So, that's going to be important to understand the domain restriction. Can you, 9 I heard? So the square root of 9 is, I think it goes to 10. So someone said 8. Now, the square root of 8.
Oh, wait, 16.
No. Well, 16 would be way off my graph. But here's going to be an important point. That what we're putting down are rational answers, right? Not irrational. But if I do the square root of 8, does that answer really exist? Yes, but it's irrational on my graph. So is it easy to figure out where 2.81 is or whatever? No, right? So even though 8 gives me some irrational answer, right, that I'm probably not going to put down on my graph, it still exists. Are the only points that exist are the ones I put down? But in between the points also exist. They are just irrational, but they exist. But when I put in a negative number, what happens? So what's the smallest x value that you can take the square root of? And the answer is 0. So our graph is going to start at 0 and curve up to the right slowly. And know that all the points in between the rational answers are still real. They exist and they're on my curve. They're just irrational. That makes them difficult to plot. But can you have a negative answer in the square root? No. So let's fill this in. I don't like the word end. I like the word start. What point are you going to start with when you graph this? And the answer is the starting point is at 0, 0. Domain. Are there any restrictions? Yep. What can x not be? Negative. So I said the smallest number x could be is 0, and then all positive numbers are fine. So the domain goes from 0 to infinity, which is a way of saying no negative numbers. How about the range? What do you notice about the y answers? Is it possible to get a negative answer when you take the square root? So the smallest answer for the range is also 0, and it goes to infinity. What does this curve remind you of if I turned it sideways? So if I turn it, doesn't it remind you of the curve of a parabola, but just half the curve of a parabola? Good. Keep that thought in mind. All right, let's do the next one. Do you know what cube root looks like? Cute little 3, right? So can you write down the cube root of x? I'm going to remind you, even though you know this, the cube root means what number 3 times itself. So we're going to do a table of values. And we want to know what the graph looks like. So I'm going to give you a number to start with. What is the cube root of 0? What number 3 times itself equals 0? Good. We'll do easy first. How about 1? What number 3 times itself equals 1? Now I need you to think. So I need you to first think, does 2 exist? It's just irrational. 3 exists. It's just irrational. The next rational answer is 8, even though that it exists in between there. They're just irrational answers that I don't want to put on my graph. So what number 3 times itself equals 8? And that's going to take us on the, as far as we can go on the graph, to the right. And then I have an important question to ask you after that, which is what happens with negative numbers? So, can you see what's happening to the right? They look similar, right? But which one is flatter? So a cube root increases slower. The square root actually rises faster than the cube root. It takes longer to rise. Yes? That's what we're going to ask, right? Amelia, man, if we turn a corner. So, is there a number 3 times itself that equals negative 1? And this has a distinction different than the square root. So what's negative 1 times negative 1? So negative 1 times negative 1 is positive 1 times negative 1 again makes negative 1. In other words, negative numbers are okay.
At this time, all 9th, 10th, and 11th grade students who are not in their first period classroom need to return to their first period class. Again, all 9th, 10th, and 11th grade students who are not in their first period class need to return to their first period classroom. Thank you.
All right. She's forever on the internet. So, can I make sure you're clear about this? Can you take the square root of a negative number? No. Can you take the cube root of a negative number? Yes. And so, do you see the extra points here? So, I don't know what that picture reminds you of. It might be like a snake or an S or something like that, right? That kind of slithers along there. Let's fill this in. We don't have a turning point. We have what's called a point of inflection. Which means at that point, it curves differently. So at our turning point there for the point of inflection is at 0, 0. Up to 0, 0, it smiles. And then after 0, 0, it frowns. That's called concavity change. So it changes concavity from concave up to concave down, and that point is called the point of inflection. Domain, you're going to like this. The domain of a cube root is, and the range of a cube root is, and it never changes. For a square root, when you do transformations, your domain and range can change. But for a cube root, it will always be all real numbers. Hey, we got this from, remember doing reciprocals? So, when you are graphing a radical, do you see the h inside? Is that horizontal or vertical shift? So h is the horizontal shift, and if you see plus, which direction are you going? Left. And if you see subtracting, what direction are you going? Right. Let's try it again. What do you think K is outside? It is the vertical shift. If you see adding, it goes up, and if you see subtracting, it goes down. Your end or turning point is going to be HK. So that point will either be your starting point or will be your point of inflection. So that HK is important there. If A is negative, the function is reflected across the x-axis. This is exactly the same as what we had in our notes, right, for reciprocals. If A in front is a big number, bigger than 1, then it's a vertical stretch. If A is a fraction in front, it's called a vertical compression. So first we're going to understand transformations, and then we're going to graph. So can you just describe the transformation that you see? So first of all, number one is what type of radical? This is called square root. Yes? What does the 7 do? What type of shift? So what type of shift? So horizontally, which way are we shifting? And then what does the 2 do? So the 2 is what type of shift? A vertical shift in what direction? So we're going to start with the word vertical or horizontal and then describe it. And if it's the 4 in front, if you multiply by a number bigger than 1, it's called a vertical stretch. And you notice the subtract 1 is outside the radical sign? So outside the radical sign means it's vertical. And instead of a stretch, it's a shift. In what direction is it going? Number 3 is called a cube root function, right? But it's the same rules for transformation. What does the negative do? It reflects, right? Across the x-axis. What does the plus 3 do inside? Good. Horizontal shift in what direction? Left how many? Got it. See how we're putting the pieces together? What does the 1/2 do? We're just going to go one piece at a time. Because it's less than 1, it's called a vertical compression of 1/2. What does the negative 2 do? It's a horizontal shift in what direction? Right or left? To the right. And how about the subtract 6? That's going to be vertical. What direction? Up or down? How many? So, can you describe the transformations that you see? And we're starting with the word horizontal or vertical. And then is it a shift, a stretch, a compression? And then by how many numbers? Turn the page when you're ready. It says the square root function is reflected across the x-axis. It is then shifted 7 units left and 1 unit down. Can you write an equation that describes it? So we're going to write down f at x equals, and we have a square root sign, right? It's a square root function. If it's reflected across the x-axis, in front of the square root sign will be a negative. It goes 7 units left. That means inside, what sign will I see? Plus 7. And then 1 unit down is outside. And what do? Subtract 1. Can you try number 6? Can you write a cube root function with those transformations? So I'm going to start with a cube root. So a cute little 3. When you do a cube root, can you make sure the 3 is small and inside the V? And not a big 3 in front of it, but a little cute little 3 inside the V? So it says a cube root function has a turning point at what? At negative 2 and 3. Write an equation that could represent it. So in other words, negative 2 is h and 3 is k. So for h, I need to change the sign. So it's x plus 2, but you keep k the same, and you did it. And you could put any number you want in front, and it would be accurate. All right, let's get to graphing. So, number 7, step 1. Is this square root or cube root? So for square root, we're going to start with 3 parent points. Remember we did this for reciprocal? And we're obviously going to pick 3 easy points to transform. which are 0, 0, 1, 1, and 4, 2. Do you remember that from the table of values? We're 9, 3 probably will be off our graph maybe, so I'm going to leave it alone. 0, 0, 1, 1, and 4, 2 are good. Do you see anything under the square root sign that changes x? Or did x stay the same? So x stays the same, so I'm going to write down x stayed the same. All the x coordinates stayed the same. Do you see anything outside the square root? That's called a vertical shift. Up how many? So to every y coordinate, we're going to add 5. Then I'm going to take these points and put them on my graph. So 0, 5, 1, 6, and 4, 7. We need to remember what the curve looks like. The mistake that some make is that when you graph this, you start graphing like this. Do you see that as a mistake? We don't want to start there. Where do we start the graph? Right there. Can you put your pen right there? And then you curve from there and connect the other points. Kind of looks like a shooting star. But we don't want to start it before. Right at that point we start. What's the domain here? And do you remember our starting point? Your domain and range is going to come from there. So what's the smallest number x can be? And it goes to infinity. What's the smallest number y can be? Comes from the starting point. 5, it's been shifted, right? And it goes from 5 to infinity. Our starting point was at 0 and 5. Do you see how they match? They're always going to match. Well, in behavior, remember this? As x approaches infinity, what does f at x approach? Where is this going? Exactly. Slowly, but as this is going up as this is going to the right. Now this one's going to be trickier because we're not going to negative infinity. Instead, we're going to, what's the left end of my graph? And as x approaches 0, what does the function approach? And it comes from the starting point. The function approaches 5. Where is this function increasing? Where does it rise to the right? And it rises from 0 to infinity, and it's never decreasing. So there's no part where it turns and then goes down. It's going up forever. All right, number 8. Step 1, it's square root. Because I know it's a square root, what are my 3 parent points I'm going to start with? 0, 0, 1, 1, and 4, 2. Look inside, underneath the square root sign. What am I going to do to each x value from underneath the square root sign? Add 1. Can you add 1 to everything? So, underneath tells you what to do with x, and it's the inverse of what you see. So if you see subtracting, you add 1 to all the x's. How about outside, what do you see? So I'm going to subtract 4. I'm going to subtract 4 to all the y's. Can you make your curve using those 3 points? The domain. The domain comes from your starting point. So the smallest number for x is 1, and it goes to infinity. The range, the smallest number is -4, and it goes to infinity. And we already said that 1 and -4 is where we're starting our graph. As x approaches infinity, what does the function approach? Infinity. As x approaches 1, what does the function approach? -4. It's increasing from 1 to infinity, and it never decreases. On to number 9. So to start graphing a square root, how do I start it? What do I write down? 0, 0, 1, 1, 4, and 2, and I'm going to make my butterflies. What do you notice underneath the square root sign? How are the x's going to change? Will I add 1 or subtract 1? Good. So to every x, I'm going to subtract 1. Look what's outside the square root. Am I going to go times 3, add 3, or divide by 3? And the answer is you're going to multiply times what? So that creates a stretch when you multiply. So every y we multiply times 3. Now go to your graph. This one you'll see a bit of a stretch in the curve. Do you see how the square root got stretched out? It's a little wider, right? How it's shooting, how the star is shooting. The domain comes from your starting point. So the smallest number for x is -1, and it goes to infinity. The smallest number for the range is 0, and it goes to infinity. The starting point was at -1, 0. Our end behavior. As x approaches infinity, the function approaches infinity. As x approaches -1, the function approaches 0. And it's increasing from -1 to infinity, and it never decreases. Turn the page. This is a square root. How do I start a square root? 0, 0, 1, 1, and 4, 2. Where do I look to see how x has changed? And you look under the square root sign. Do I add 2 or subtract 2 to all the x's? So we're going to add 2. Now you look in front and behind. Do you see something in front of the sign? Do you see something behind it? So we have to do two things. The negative, we're going to go times -1, or change the sign, and then we're going to add 3. So what's 0 times -1? 0, and then add 3, and you get 3. Again, 1 times -1, -1 plus 3 is 2. One more time, 2 times -1, -2 plus 3. And those are our points. It's going to curve a little differently this time because of the reflection. If you see it as a sideways parabola, it's now the bottom half, right, of the parabola rather than the top half. Now, the domain still comes here. So the domain still is 2 to infinity, and the range is 3 to. Now, this one's going to change. Let me try this again. What direction is the curve going? So the bottom of the range is actually -infinity, and it goes up to what number? So 3, and this should be a parentheses. So it goes -infinity to what number? Because of the reflection, this now is the top point, right, of the curve. So the bottom is -infinity, and the top is 3. Where's our HK? Our starting point is at 2, and as x approaches infinity, the function now is going where? To -infinity. It's going down. As x approaches 2, the function approaches 3. This is not increasing, but instead decreases from 2 to infinity. So notice what the reflection does. Now it's going down rather than going up. How about number 11? What type of function is number 11? Cube root. So these are the cube root parent points we're going to use. Do you remember 0, 0? You remember 1, 1, but we're going to add another one, which is 8 and 2. We also need -1, and there are 2 extra parent points to get the curve, because there's more to it. What do you see under the cube root sign? Should I add 3 or subtract 3 to all the x's? So I'm going to subtract 3 to all the x's. And if it's not on my graph, I won't graph it. So -8 will probably be off my graph, but it's okay. So when I subtract 3, I get -11. That might be a little off my graph. What do I do with each y coordinate? Add 2, and it does what it says. Go to your graph. So I'm going to start with -3, 2, then -2 and 3, and 5 and 4, that's half the curve. How do I find the other half? So -4 and 1. -11 and 0 is like, I'm just going to add a point right there where the tip of the arrow is. This is the good news. What's the domain and range? All real numbers. It never changes. Our turning point is our point of inflection, which is at -3 and 2. As x approaches infinity, the function approaches infinity. As x goes to -infinity, the function goes to -infinity. This function is only increasing and never decreases. So from left to right, it's only going up. It will never turn and go the other way. So they say a cube root is monotonic. It only goes one direction, either always increasing or always decreasing. All right, 2 left, and then your homework. So number 12. What type of radical is this? What are the parent points of a cube root? That's something we need to memorize. And then we're going to make the butterflies. First thing you look at, look under the cube root sign. Is x changing or does it stay the same? So every x is going to stay the same. Next, can you look in front or what follows? Is there anything in front of the cube root sign or following it? And what do you see in front? -2. So we're going to multiply every y coordinate by -2. So 0 times -2, 1 times -2, 2 times -2. You get the idea all the way down. Now we have points to plot. And then can you make your S? I guess in this direction it's not an S because it's been reflected. Can you make your snake all the way across? Remember, what's great news about the domain and range? It never changes, right? Where was our point of inflection? At 0, 0. As x approaches infinity, this time the function goes to -infinity. So the right end is down and the left end is up. Where is this increasing? Nowhere. Where is it decreasing? Everywhere. So the whole function's going down from left to right. One more together. Number 13. This is a cube root function. What are the parent points for cube root? 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. Can you make the butterflies? So I'll give you a chance. So this morning, I'm going to send you this video and the homework video. And there's a summary sheet, too, like the last sheet. So continue, find the butterflies. Tim Gertz here. Oh. Yes. Yes. Michael, can you go to the counseling office? All right, I'm going to finish this, and then you can just see the video over everything, all right? So we're going to subtract 1. No quiz tomorrow. We're going to go times a half and subtract 5. Half of 2 is 1 and subtract. So again, half of negative and subtract.
You want credit, just ask for it.
Yes. A lot. A lot, a whole ton.
All right, domain and range. You too. Always increasing, never decreasing. Mr. D Math, over and out.